we continue with the discussions of non-dimensionalization of equations of motion. A typical example that is cited in most of the textbooks is that of Bernoulli's equation. For one, it is met very frequently, it's used very widely, and it's easier to work with. So this example is a typical example that is normally discussed in textbooks for giving an example for discussing for the case of non-dimensionalization of a equation of motion. And Bernoulli's equation, you may have seen how frequently we discuss this. The equation is P plus half rho V square plus rho GZ is equal to a constant. So that is the equation that we have. Now, if we divide it to be able to non-dimensionalize it, if we divide it throughout by some pressure, in this case called as P infinity, then we see that it turns out to be non-dimensionalized. And we see as a result of which what happens to each term. So you can see the first term that we have is pressure, and when we will divide it by a typical pressure from the fluid flow situation, then pressure over pressure will have the same dimensions. We are talking of the first term on the left hand side, and so that the dimensions of this will become 1. Otherwise, what is pressure? Pressure will have the dimensions of force per unit area. So the dimensions of force divided by the dimension of area will determine the dimensions of the term pressure. We see that if we divide the second term, which is half rho V square, by pressure, then again they will have the same dimensions as that of the pressure, and therefore the dimensions of this term is also rendered as 1. Then rho GZ, again the gravitational force is there. So gravitational force is acceleration due to gravity, and it will have the same dimensions as that of the acceleration, and Z is a height, so having the dimensions of length of one dimension. And if we divide it by the dimensions of the pressure, that also brings it to 1. And the right hand side is constant. Constant divided by the pressure will also reduce the same thing. And remember that the dimensions I already mentioned, that they must have, each term must have the same dimensions. So the dimensions of C on the right hand side will also have the same dimensions as that of the pressure occurring at the first term in Bernoulli's equation. So each resulting term then becomes dimensionless when we divide by pressure. We have equations of motion, F is equal to ma, or in gravitational forces, the d2z by dt square is equal to minus t square, or this can be the same as d2x by dt square is equal to minus some other term that we may write is equal to, plus a. Because the left hand side is going to give us acceleration, d2x is, as you can see, it is d by dt of dx by dt is equal to d by dt. This is velocity. So rate of change of velocity with respect to time is acceleration. And if we are considering the motion in a vertical direction, that is taking place due to gravity, then we have the gravitational force occurring on the right hand side. And if we take the positive direction as the vertical upward direction, then since the gravity will always be acting downwards, therefore the negative sign is appearing there, and that is the reason why we have a negative sign on the right hand side in the first equation. If we integrate this equation with respect to t, then you can see that d2z by dt square times dt minus g dt, the result, if we integrate this 2 times, we shall be obtaining this result. Z is equal to z naught, which is some constant of integration, plus w naught t, where w naught is a velocity at t equal to 0 minus half gt square. So this arises as a result of integrating the first equation. The same thing is shown here in terms of pictures, that the positive direction is taken to be the z direction in the upward direction, and that is the direction of the velocity. And if the gravitational force is acting downward, since that happens that way, we have a minus sign there. So if there is an object that is falling in a vacuum, then you can see the picture as depicted here, and omega w has to be negative, showing only the case or direction. The absolute value of velocity w in the vertical direction will be some non-zero value, but negative sign only shows that we are taking the positive direction in the upward direction while the body is moving in the downward direction.